Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker. This is chapter 12, part 3, multiple linear regression. So there is a lot of vocabulary in this chapter. So I want to encourage you to go back and read the book about all the different pieces because it's easy to get lost if you don't focus on the vocabulary. So remember, we were talking about the extra or sequential sum of squares, which were the sum of squares due to regression of these additional predictors given a model that already has some reduced sets of predictors. So what's the additional sum of squares of xg plus 1 up to xk, given you already have x1 to xg already in your model? Okay. The way that we can calculate this extra or sequential sum of squares is by taking the sum of squares regression of the full model minus the sum of squares of regression of the reduced model. Okay, let's note a few things. When we add more predictors, the sum of squares due to regression should become bigger, and the sum of squares error is going to become smaller. Why is this? Well, if we have more information, we should do better at predicting y. Unless that information is totally bogus and leading us off track, it will be true that your sum of squares regression of your full model should always be bigger or equal to the sum of squares regression of the reduced model. Similarly, your error should go down because if you have more information, you should make less errors. Your sum of squares error of your full model should be less than or equal to the sum of squared error of your reduced model. So we will call the sum of squares regression of x1 to xg. That's the variation in y that can be explained by a model with x1 to xg in the model. Your sum of squares regression of x1 up to xk, that's the variation in y explained by a model with x1 to xk in the model. Your sequential sum of squares, or your extra sum of squares, that's the sum of squares due to regression of xg plus 1 up to xk, given x1 to xg are already in the model. This is the extra variation in y that can be explained by adding xg plus 1 up to xk into the model that already has x1 to xg in it. So overall, if adding the xg plus 1 up to xk into the model helps explain the variation in y substantially, then xg plus 1 to xk should be included in the model. And those slopes associated to those predictors, the beta g plus 1 up to beta k, at least one of those slopes is different from 0.